This is the solution class for the circular motion gravitation worksheet. So we're going to continue our solution process within this worksheet. So let's just bring in the whole PDF here. Okay. তোমাদের কারো কোনো did you attempt something and that couldn't solve it, এই ধরনের সিচুয়েশন হয়েছে? আজকে কি সলভ করার কথা ছিল না নাকি বুধবার সলভ করার কথা? আজকে ঠিক আছে। Okay, so let's have a look. We did discuss about this one. This is doable. This is also doable. আচ্ছা, number 6 টা দেখাই। Number 6 টা দেখো, explain what is meant by gravitational field. This is just a definition. You write the definition of the gravitational field. In B, it says a spherical planet has mass m and radius r. The planet may be considered to have all of its mass considered at the center. The reason they have given us this sentence is so that we can apply the Newton's gravitational law without any shortcoming. So that because that law is applicable for point mass. A rocket is launched from the surface of the planet such that the rocket moves radially away from the planet. The rocket engines are stopped when the rocket is at a height r above the surface of the planet, as shown in figure 1.1. The mass of the rocket after its engines have stopped is m, which means at point r, its fixed mass is m. The reason they have mentioned about the rocket's engine stop, because as long as the engine will run, the rocket will actually burn the fuel gases and actually lose mass. So that's why they have mentioned that after the engines have stopped, the mass is m. Show that for the rocket to travel from a height of r to a height of 2r above the planet's surface, the change in EP in the magnitude of the gravitational potential energy of the rocket is given by the expression delta EP equals to gmm by 6r. কখন কতক্ষণ ওরা এখানে ঢুকছে, কার করে যাবে? খুশি হলাম। ওকে, সো এটা খুব ডিফিকাল্ট না, I'm just going to show you the process. What is important for you to observe that it is traveling from r to a height of 2r. So this is our final distance, this is our initial distance. So delta AP is given by mass times delta phi, which can be written as mass into final potential minus initial potential, which can be written as mass multiplied by minus gm by 2r minus gm by r. You can also go ahead to write this in under horizontally below. I just prefer it to do it this way so that I can utilize the maximum amount of space over here. Then you simply just do the LCM, which gives you this is gonna be, I should not write. If I just take the GMM out, which I can, this is gonna be 1 by r minus 1 by 2r. What does this become? কোথাও কি ভুল করতেছে?
স্যার ওয়ার্কশিটটা কি আপনি গ্রুপে সেন্ড করেছেন?
প্ল্যানেটের রেডিয়াস কনসিডার করতে হবে না।
পুরো ওয়ার্কশিটটা ওয়েবে সেন্ড করা যাবে, বাট আমার এই পুরো ওয়ার্কশিট ওয়েবে আর আটবে কিনা এটা হচ্ছে কোশ্চেন। তোমরা কি প্রিন্ট করে নিতে যাচ্ছ?
অ্যাট লিস্ট সলভ করার জন্য ওয়ার্কশিটটা লাগবে।
আচ্ছা, আমি তোমাদের ইয়াতে লিংকে দিয়ে দিয়েছি, সমস্যা নাই। ওয়ার্কশিট মার্কস কিন্তু দুটো দিয়ে দিচ্ছি, নো প্রবলেম। এটা হচ্ছে ওয়ার্কশিট মার্কস। আমি দেখতেছি যে এগুলো যাবে কিনা, কারণ তোমার মেসেঞ্জারে তোমার হচ্ছে মনে হয় 15 MB বেশি কোনো কিছু শেয়ার হয় না, সো ওই জন্য ওটা দেখতেছিলাম। হ্যাঁ, আমি ওয়ার্কশিট দিয়ে দিয়েছি, যারা কালেক্ট করতে পারতেছে না ফর দ্য টাইম বিং ডিউ টু দ্য strict, I'm flexing my fingers, strict কি বলে লকডাউন গেছে, এখান থেকে ডাউনলোড করে প্রিন্ট নিতে পারো, সমস্যা নাই, নো প্রবলেম। এটা এলসিএম করলে কত আসবে? 2r উপরে আসবে হচ্ছে 2r মাইনাস r। আমি ভুল করতেছি কোথায়? r2
Sir, Earth
ও
radius
আচ্ছা
consider
আচ্ছা 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 আচ্ছা, আর্থ রেডিয়াস কনসিডার করতে হবে। So it was taken from here to here. We are asked to find out the GP for this much distance, but practically for the planet, from the center of the planet, it was actually moved from total distance 2r to a total distance of 3r. So আমি ওই জিনিসটা করতে ভুলে গেছিলাম, the most common mistake that is. So this should be 3r and this should be 2r. So yeah, so now we're gonna have 2r minus 3r. So এখন এটা এলসিএম করলে ইজিলি gmm by 6r চলে আসবে। এখন ঠিক আছে, এই মিস্টেকটাই হয় মোস্ট অফ দ্য কেসেস, এই মিস্টেকটাই হয় কোশ্চেন ঠিক মতো না পড়লে, এবং সেই মিস্টেকটাই করতেছিলাম। হাউএভার আই ওয়াজ লাকি যে এখানে আমাকে এক্সপ্রেশনটা দেওয়া ছিল, ইট ওয়াজ এ শো কোশ্চেন, নট টু ক্যালকুলেট করতে হলে হয়তো আমি ভুল লিখে চলে যেতাম। জাস্ট বি কেয়ারফুল দ্যাট হোয়াট আর দ্য ভ্যালুজ অফ আর দ্যাট ইউ আর ইউজিং। আচ্ছা, এরপর আমাদেরকে কোশ্চেন বলছে ডিউরিং দ্য ascent from a height of r to 2r, the speed of the rocket changes from 7600 meter per second to 7320 meter per second. Show that in SI units the change in delta E in the kinetic energy of the rocket is given by the expression eta. So eta kora খুব difficult na. This is basically half m of v initial squared minus v final squared. They are considered as speed, so you don't have to bother about big minus small. This is a change, so you can put any of the values here, you get this number. This is okay. The next question, the planet has a radius of this much meter. Use the expression b to determine the value for the mass of the planet. So use the expression in b. So what is the expression that we got from b? In b we got this expression, that this is the amount of change of ep. So as the rocket traveled from here to here, you have to understand that the engine was stopped at this point. Have a look. Have a look at the question once again. A rocket is launched on the surface of the planet as the rocket moves radially away from the planet. The rocket engines are stopped when the rocket is a height r above the surface of the planet. This is where the engines were stopped, but that doesn't mean the rocket actually came to a stationary state. It did have some kinetic energy at this point, and at our distance, as per the question, the velocity was, or the speed value was 7600 meter per second. Then the rocket fleeted away. I mean, because of its inertia, it moved from the surface, it moved from the r distance to the 2r distance, and in that process it lost some kinetic energy because it slowed down, because it was doing work against the planet's gravitational field. So what this question is asking us, use the expressions in b to determine the value for the mass of m of the planet. Within this travel from here through here, the rocket did not burn its engine, so it did not convert any chemical energy to any other form of energy. So it means basically put the amount of GP change necessarily came from the amount of K drop. So we have to equate these two expressions, and we can actually go on to find out the mass of the planet. So this is actually GMM divided by 6R. This is the value of R. They have already given us this value. This should be equals to this number, which is 2.09 into 10 to the power 6 multiplied by m. So m and m crosses out, r এর ভ্যালু এখানে বসাবা, g এর ভ্যালু এখানে বসাবা, সো এখান থেকে ক্যাপিটাল m এর ভ্যালুটা বাইরে হয়ে আসবে। এইটুকু হচ্ছে সিম্পল। এইটা হচ্ছে ইম্পর্টেন্ট কোশ্চেন যেটা অ্যাকচুয়ালি আলাপ করা দরকার। স্টেট ওয়ান অ্যাজাম্পশন মেড ইন দ্য ডিটারমিনেশন অফ ওয়ান। হোয়াট ইজ দ্য অ্যাজাম্পশন মেড ইন দ্য ডিটারমিনেশন অফ ওয়ান? আচ্ছা, এখানকার অ্যাজাম্পশনটা হচ্ছে দ্য টোটাল জিপি গেইন was provided from total K provided, which means this entire system that is built up considering the planet and the rocket, it was considered to be an isolated system. Isolated system means that we are trying to consider a setup where in the entire visible considered volume of space that we are judging in our thought process, there is only the planet and there is only the rocket. They are located in the vastness of the space and nothing is around them, and they are, all of their used energy are contained within the system, and there is no other planet to provide any more gravitational pull. There is no other any other satellites around here to produce any other gravitational field. So they are the only two objects which are considered for the scenario. That's why the energy conversion is limited within themselves. So that's the basic idea, that you can either say that the rocket and the planet are considered to be an isolated system, or you could also say that the energy, kinetic energy lost by the rocket was altogether converted to the GPE gain of the rocket because there is no other gravitational field producing source. The second definition is basically what it means by the term isolated system, but typically the examiners prefer the wording isolated system. If you have a look at the mark scheme, this was for question number what? This was for question number 6. If you have a look at the mark scheme for this wording, let's have a look. Oh, I'm talking. My bad. 6 বলছে হচ্ছে example, no energy dissipate due to friction or with atmosphere or air. A rocket is outside the atmosphere, not influenced by any other planet. So these are example answers. So you can write any of these things. They did not provide this is an isolated system. Okay. If you have a look at the examiner's report, it says there were many trivial answers. Let me zoom in. There were many trivial answers such as no energy losses or changing kinetic energy, potential energy are equal. So these were considered trivial. Such responses are inadequate for A level. So you see, if you just mention that the energies were equal, that's basically what you're doing. But why are you able to do that? You have to mention that. Such responses are inadequate for A level. A reference to energy conservation should include how energy is lost from the system. A number of candidates made reference to the possibility of another large mass giving rise to a force on the rocket, which is absolutely wrong. So that's basically it. So there was no energy dissipation. So you can see the answers. These are all example answers, which means if you write the other expression that I told you, that the rocket and the planet together are considered as an isolated system, this will also give you full marks. 1. There's only 1 mark here. That's also perfectly okay. So that was for question number 6, which is interesting question. And then we have this one. Okay, yeah, this I would like to discuss. This is a discussion that is really good for the thought process. So let me just go for this thing. Question number 7, have a look. Define the radian. I did not teach you the definition of radian because I assume that you know how to define the unit of angle, radian. If you are ever to define the radian, other than trying to, if you forget the actual word equation, the word definition of this type of definitions, you can always go ahead and write the equation that theta equals to S over R, and then from there you can write 1 radian, or you can write 1 radian is the ratio of arc length made by unit radius. So the amount of arc length made by unit radius is the ratio of these two things is 1 radian. Because I did not teach you this definition, so I'm going to have a look at the mark scheme to give you an idea of how they expect it to be. Angle subtended at the center of a circle. So you have to mention that, which I didn't mention, by an arc equal in length to the radius of the circle. Examination report says a significant number of candidates attempted to define the radian measure rather than the radian itself. Frequently, it was not stated that the angle is subtended at the center of the circle of which the arc is a part. So the part that I missed out in my answer, that was actually a very common mistake. So you should see over here, this is a 2-mark answer. So you have to give both of these statements. Radian means an angle that is subtended at the center of the circle by an arc equal in length to the radius. So I might as well star mark this question because this is a question that is not covered in the basic theoretical discussion. Might as well look at this definition every once in a while. You go through the worksheet or revising these chapters, so that you actually don't forget how to write this answer. I would appreciate if you put a star mark for this question. Where are we? Here. Okay. Number 2 says a small mass is attached to a string. The mass is rotating about a fixed point P at a constant speed, as shown in figure 1.1. Explain what is meant by angular speed at point P of the mass. So you have to define the term angular speed. It is the amount of, it is the measure of angle subtended by the string at the center of the circular motion in unit time. So basically, they're asking us about angular speed. So if we recall the formula, omega is given by theta over time. So angle subtended in unit time at the center by the string, which should be produced at the center. So that should come along as well. These are very basic definitions, but once again, they have 2 marks each. So be careful about these definitions. You might feel that you are good at these things, but in many cases, students tend to lose marks in these parts, and because they don't put the extra effort to really precisely know how the examiners want the answers. So please be careful about these small descriptive questions. If you lose, let's say 1 or 2 marks in all the 12 questions, you might as well come short of 12 or 24 marks within a 100 paper question, 100 marks paper. So you do not want that to happen to yourself. Just be careful. That's what I'm asking. This is the question that I'm interested about. Have a look at question number B. A horizontal flat plate is free to rotate about a vertical axis through its center as shown in figure 1.2. Okay, this is a horizontal plate. It is free to rotate about the vertical axis through its center. Free to rotate means there is no friction in the process of the rotation. Whatever the rotating thing is, a smooth ball bearing, whatever bearing. A small mass M is placed on the plate at distance d from the axis of the rotation. The speed of the rotation of the plate is gradually increased from 0 until the mass is seen to slide off the plate. Try to visualize this process. We have placed this mass over here, and then we have started to rotate the disc. This mat is not glued or attached anyhow. It is just placed over there. So it is basically staying over there because of its gravity. And because of the gravitational force, there would exist a certain frictional force between the mass and the top surface of the plate. As we start to rotate this plate, that frictional force will be responsible to provide the centripetal force required for the mass to go along, because friction will try not to allow this thing to move with respect to the plate. The question says that the speed of the rotation of the plate is gradually increased from 0 until the mass is seen to slide off the plate. So we have increased the angular speed of this plate till the point the mass actually slided off the plate. Now, if you wonder why should the mass slide off, this is a part that I would like to discuss. Here is the deal. If I draw the top view of this setup, let's say this is the disk, the top view, here is the center of the disk. Let's say the mass is over here. As the disk will rotate at every single instant, if you're speeding up the thing, is going to require some significant change of the centripetal force. Slowly, this linear speed is going to become bigger and bigger and bigger. And so I'm trying to draw increasingly bigger size arrows with equal distance apart. Let's say this is the trajectory of this mass, and it goes on in a circular path with a radius of d over here. But you have to understand that Fc is given by mv square divided by r. So the required centripetal force for this mass to maintain the circular motion while the angular speed is going up, so the v is going up, so the requirement of Fc will also go up. Now you need to ask yourself, what is the source of this Fc? Where is this Fc coming from? This Fc is basically coming from the friction between the mass and the top surface. Why the friction is responsible? Because you have to understand that for this visualization, the weight is actually working vertically downward. So I might as well draw the direction of the weight with a cross, because cross means into the page. So for this view, weight is working into the page. But the centripetal force required is working towards the center, that is on this surface, along the surface. So the mass is gonna still be able to keep its position on the disk as long as the required centripetal force does not surpass the maximum frictional force. What do I mean by this? Let me elaborate this point. Let's say the maximum frictional force that exists between the mass and the whole thing is, let's say, 10 Newton. I'm just assuming this number, which means this is the maximum force due to friction max. So let's say this is the maximum frictional force. So whenever we are slowly speeding this up, so the centripetal force requirement is going to slowly become bigger. So and for every single instance, you have to understand this is the maximum value of frictional force. It is not a steady value. What do we mean by maximum frictional force? Try to understand this thing. If you have a fixed surface and if you have an object over here, and if you press the object, let's say by 1 Newton force, and if it doesn't move, it means friction is opposing its motion by exactly 1 Newton as well. So together the resultant is 0, it's not moving. If you push it by 2 Newton force and the object does not still move, it means the surface is capable to produce 2 Newton of friction. If you keep on increasing this applied force, there would come a point when this object would start to move away. That value of force is basically the limiting value or the maximum value of friction that the surface, the contact between the object and the surface can provide. In this case, I'm assuming that force is 10 Newton. So whenever the disk is speeding up, the requirement of FC is going to slowly go up. So let's say the initial, when the disk is stationary, it was 0 Newton, then it is slowly going to increase 0 to 1 to 2. It actually increases continuously. And till the moment the required centripetal force become perfectly 10 Newton. Whenever the object speeds, whenever the disk speeds up even by a little further, then the required centripetal force become bigger than 10 Newton. Let's say something bigger than 10, let's say 10.001 Newton. I'm just giving a very small value. This surface cannot provide that much frictional force, which basically means that required acceleration will not be provided, which means the object would actually not be able, I shouldn't draw here. Let me show over here. Let's say from here, as the object moves up to here at a certain speed, it requires a certain amount of force to maintain its centripetal acceleration. If whenever the object speeds up that much beyond a certain value, the amount of force that is going to require to achieve that much acceleration so that it can actually still stay on the plate will not be provided from the friction. So what's going to happen? The amount of direction change of the velocity that you are expecting to happen, that amount of direction change will not happen. So there will be less amount of direction change. So the object will not be actually going in this way. Rather, the object would start to slide off with a less amount of velocity change, which would be somewhat like that. So let's say the angle over here is less, but we should see the angle between this initial direction and this direction was more. The angle between this initial direction and this final direction is actually less, which means the object is not changing its direction as much because it simply does not have that much supply of force anymore. So this is only possible if the trajectory slowly starts to get bigger, because the maximum surface friction can be 10 Newton. So if you have a look, if you fix this value, if you want to fix this value at 10 Newton, this is, let's say, perfectly 10 Newton, and you still want to increase the V, the only way you can still keep this 10 Newton is only if your R also goes up. Do you understand my point? I'll write again here. Let's say FC equals to mv square divided by R. Your maximum value for friction for the centripetal force availability is 10 Newton. So if you keep on speeding up the whole thing till the point 10 Newton is not reached, you can still keep the mass at the same position on the table, on the rotating table. But whenever your speed goes such high that your required centripetal force is more than 10 Newton, which you cannot achieve from the physical source that you're getting, so you simply cannot have more than 10 Newton of centripetal force. So what's going to happen? Your speed is going up. So to make this whole ratio equal to 10 Newton, you see, mass is not going to change. Your radius should definitely go higher, right? So that the total ratio still remains 10 Newton because R is on the denominator side. If V square is getting higher, but so to keep the value constant, your denominator should also become higher. Does this logic make sense?
Yes, sir.
If you have any question, please ask me or raise your hand or please write in the chat box so I can actually respond to your queries. So this is the point when the mass would actually be seen to slide off, and pretty much soon it will actually fall off. One of the qualitative way to describe this behavior is that the inertia of the mass actually causes it to slide off. But why does the inertia of the mass cause it to slide off at that or beyond that fixed velocity actually comes from the discussion of the availability of the source of that friction of the centripetal force. I've told you earlier in the theoretical classes that any object that undergoes circular motion, we call the force that causes circular motion basically centripetal force. But that centripetal force can come from a lot of different physical happening. For this, so for the galaxies, it's a gravitational force. For the atom, is a electrostatic attraction forces. For string attached mass, it can be the tension of the string, blah 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 blah. So over here, friction is the reason for which the circular motion was happening. So I've told you the basic for how this thing actually is going to work. So we can start the process of solving this paper. The question says that the maximum frictional force between the plate and the mass is given by the expression F equals to 0.72 W. So this is the maximum frictional force, where W is the weight of the mass M. The distance D is 35 centimeter. Determine the maximum number of revolutions of the plate per minute for the mass M to remain on the plate. Explain your working. So they've asked us to explain our working. This is a 5-mark question. Take a good look. This is a 5-mark question. So you have to write some amount of explanation before you start working, or after you write, do your working. You have to provide why you believe that was true. If I was answering this question, I would write that for the mass to remain on the plate, frictional force provides the centripetal force. The mass starts to slide off when the required frictional force, the required centripetal force surpasses the maximum frictional force. Required centripetal force surpasses or is more than the available frictional force. So till the point it actually stays on the same spot on the disk. Till the instant it stays on the disk. For that thing, we can write that centripetal force is equals to the maximum frictional force. So I'm going to write F max. So that can be written as M. They are asking us to find out the revolutions of the plate per minute. So it's basically omega. So I'm going to write this expression in omega square. M omega square R equals to 0.72 mg. Might as well delete this vertical line. Okay, so let me write this over here. I have written the W expression in mg term so that I can get rid of the M and M right in this equation, and G is over here. So from here we can calculate the omega. Can someone calculate the omega for me? This would be root over 0.72 multiplied by 9.81 divided by 0.35. দেখো তো ওমেগা ভ্যালু কত আসে। এটা আসবে রেডিয়ান পার সেকেন্ডে। এরপরে সেটাকে আবার আমরা রেভলিউশন পার মিনিটে কনভার্ট করব। কেমনে কনভার্ট করব সেটা তোমাদেরকে দেখাচ্ছি। তোমাদেরকে তো রেভলিউশন পার মিনিটে ক্যালকুলেশন দেখাই নাই আগে, দেখাইছি?
স্যার
দেখাইছি? ইয়েস অর নো? না। আচ্ছা দেখাবো। এটা একটু ক্যালকুলেট করে দেখো কত আসে। 0.72 9.81 divided by
4.49
4.49 radians per second. আচ্ছা, আমি আরপিএম এর কনভার্সনটা একটু এখানেই দেখাবো, বাট তার আগে তোমাদেরকে আরপিএম কনভার্সনের বেসিক কনসেপ্টটা বলি। Try to understand this thing. If an object is undergoing n rpm, n number of revolutions per minute, এই নাম্বারটা ফ্র্যাকশন হইতে পারে, ইন্টিজার হইতে পারে, doesn't matter. If an object has n rpm, it means it is every single minute, which means within a time amount of 60 seconds, it is covering a total angular displacement, or total angle it makes at the center is n times the rotation. And একটা সার্কুলার সেন্টারে টোটাল কত রেডিয়ান অ্যাঙ্গেল থাকে? 2 pi. 2 pi. So total amount of angle it makes at the center is n into 2 pi within a duration of 60 seconds. তার মানে এখান থেকে যদি আমি হিসাব করি তাহলে আমার এটার ওমেগা ভ্যালু কত আসবে? ওমেগা ভ্যালু আসবে হচ্ছে total angle produces over total time, which basically is 2 pi n divided by 60. So এটাই হচ্ছে বেসিক ইকুয়েশন। পরীক্ষা যদি কখনো তোমরা rpm to radiation rpm to radian per second calculation ভুলে যাও, this is how you can always get to this number. nrpm means within t equals to 60 seconds it produces this much angle at the center. তাহলে ওমেগা হবে হচ্ছে theta over t, which means total angle divided by total distance. তাহলে এখান থেকে আমাদের টোটাল ইকুয়েশন চলে আসলো হচ্ছে ওমেগা equals to 2 pi into number of rpm divided by 60. এটা হচ্ছে কোর ইকুয়েশন। আর তুমি যদি উল্টাটা করতে চাও, লেটস সে তুমি যদি ওমেগা अवेलेबल আছে, তুমি n ক্যালকুলেট করতে আছে, জাস্ট এই ইকুয়েশনটাকে আমরা রিভার্স করে দেই। সো দ্যাট উইল বিকাম n equals to ওমেগা into 60 divided by 2 pi. আমি এখানে পাই বাই 30 লিখতে পারতাম, পাই বাই 30 আমি ইচ্ছা করে লিখি নাই, যাতে করে 60টাকে সেকেন্ডে মিনিট কনভার্টেড ইনটু সেকেন্ড হিসেবে 60 দেখা যায় এবং 2 pi রেডিয়ানটাকে টোটাল সাবটেন্ডেড অ্যাঙ্গেল এট দ্য সেন্টার হিসেবে 2 pi দেখা যায়। সো ওই জন্য আমি 60 আর 20টা ক্যালকুলেশন দেখাই নাই, আমি এটাকে এই ফরমেশনে লিখলাম। বুঝা গেছে এই কোশ্চেনটা? এই জিনিসটা বুঝা গেছে কিনা?
জি স্যার।
আচ্ছা, কেউ চ্যাটে একটা কোশ্চেন লিখছে 4.49। হ্যাঁ, তাহলে থ্যাংক ইউ। আচ্ছা, সো এখান থেকে আমাদের তাহলে ওমেগা ভ্যালু যেহেতু আমরা পাইছি, সো এখান থেকে যদি আমরা n ক্যালকুলেট করি, আই মাইট অ্যাজ ওয়েল রাইট দ্যাট 4.49 ইকুয়ালস টু 2 পাই n ডিভাইড বাই 60। তো এখান থেকে n এর ভ্যালুটা ক্যালকুলেট করে দেখো আরপিএম এ কত আসে। Answer equals to এত into 60 divided by 2 divided by pi. $42.9 দেখো আসছে কিনা। ভুল করছি? এটা আসছে কি সবার? প্রমাণ
জি স্যার, এটা আসছে।
আচ্ছা ঠিক আছে, ওকে। আচ্ছা, আমি একটা কাজ করি, এটাকে একটু ছোট করে আমি চ্যাট উইন্ডোটা এখানে রাখি, যাতে করে আমি তোমাদের রেসপন্স করে ইমিডিয়েটলি দেখতে পারি, নাহলে এটা মিস আউট হইতেছে। I'm keeping my chat window over here and the participants list over here. Okay. So এটা গেল। এখন সি নাম্বার কোশ্চেনটা দেখো। সি নাম্বার কোশ্চেনটা ডেফিনেটলি স্টার মার্ক করা ডিজার্ভ করে, because this is a theoretical question which has 2 mark into it. So let's have a look at this one. The plate in B is covered when stationary with mud. পুরা স্টেশনারি টেবিলটাকে এখন আর আমাদের ম্যাথটা নাই, we don't have the mass anymore, this is just a different setup, different scenario. The plate in B is covered when stationary with mud. Suggest and explain whether mud near the edge of the plate or near the center will first leave the plate as the angular speed of the plate is slowly increased. বুঝো, suggest and explain whether the mud near the edge of the plate or near the center will first leave the plate as the angular speed of the plate is slowly increased. আচ্ছা, angular speed slowly increased তার মানে হচ্ছে আমরা ওমেগা নিয়ে একটা ইকুয়েশন লিখি। একটা জিনিস খেয়াল করো, the centripetal force requirement is given by m omega square r, and the frictional force is whatever the value of frictional force is that is obtainable from the contact between the mud and the surface. এখন একটা জিনিস বুঝো, আমি আগের ফিগারটাতে ব্যাক করব। আচ্ছা, আমি নতুন একটা ফিগার রাখি, লেটস সে রাইট ওভার হিয়ার। একটা জিনিস খেয়াল করো, মনে করো এটা হচ্ছে আমাদের ডিস্ক, এই পুরো ডিস্কটা মনে করো হচ্ছে মাঠ দিয়ে হচ্ছে লেয়ার করা। ফর দ্য সেক অফ আন্ডারস্ট্যান্ডিং, if you consider two pellets of muds, two equal pellets of muds, মনে করো একটা প্লেট অফ mud হচ্ছে এই জায়গায়, আরেকটা প্লেট অফ mud হচ্ছে এই জায়গায়। When the disk is going to rotate, this radius is going to rotate at the same rate, which means within the duration, within the same time, this mud pellet is going to reach over here and this mud pellet will reach over here, because that's the whole point of angular motion. By the time this mud pellet completes one full rotation, this mud pellet will also complete one full rotation. But what I need you to see, which basically means that omega is same for every amount of mud, every mass of mud for the entire plate. সবার জন্য ওমেগার ভ্যালু সেম, এটা কি বুঝতেছো? Because all of them are covering the same angular displacement with respect to the center, subtending the same angle with the center whenever the disk is rotating. Omega is same for everyone. So what is different? The different variable is basically R. R is the different variable. And I'm, for the sake of easier consideration, I'm considering the M of individual mass pellets to be equal. Why am I considering mass pellets to have equal masses? So that I can consider them easily. So আমি যদি ইকুয়েশন এখানে জাজ করি, let's say f equals to m omega square r, এই এক্সপ্রেশনের মধ্যে ওমেগা সব জায়গার মাসের, আচ্ছা আমি এটা অ্যাকচুয়ালি ওই পাশে লিখলে ভালো হতো, এখানেই লিখি f equals to m omega square r, সবগুলা মাড কন্টেন্টের জন্য আমাদের ওমেগার ভ্যালুটা হচ্ছে fixed. So the one which are further apart from the center are going to require a bigger centripetal force. তার মানে হচ্ছে আমি যখন এই জিনিসটাকে স্পিড আপ করা শুরু করব, কোন জায়গায় মাড পার্টিকেল গুলোর ভ্যালু আগে 0.72 W এর সমান হবে, এই ভ্যালুটাকে সারপাস করবে দূরের মাড না কাছের মাড? অবশ্যই দূরের গুলা আগে 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 ক্রস করবে, কারণ হচ্ছে তাদের সেন্টিপিটাল ফোর্সের রিকোয়ারমেন্ট হবে বেশি, কারণ তাদের ডিসটেন্স অনেক বেশি। সো ওই জন্য এগুলা দেখা যাবে যে বাইরের গুলা আগে ছিটকে পড়তেছে এবং ভেতরের গুলা পরে ছিটকে পড়তেছে। This is the scientific explanation for this, or the equation based explanation for this. But one thing that is also easily understandable, that logically speaking, the mud at the center should not be seen to flow out earlier, because obviously the central mud will not actually push through the outer mud, and the outer mud, it's not actually physically possible that the outer mud stays in place and the central mud actually leaves through it. That's actually not happening because objects don't behave that way. So এটা হচ্ছে এক্সপ্লেনেশন। এখন আমি যদি এই 2 মার্কের আনসার লিখতাম তাহলে আমি কিভাবে লিখতাম? আচ্ছা, আমার এক্সপ্লেনেশন আমি নাই বলি, কারণ হচ্ছে আমি বলতে গেলে দেখা যাবে আমি 2-3 মার্ক লুজ করে ফেলছি। So let's have a look at the mark scheme and the examination report to understand how the examiners are looking forward to have this question answered. This is 7C. It says, have a look. Either centripetal force increases as R increases, or centripetal force larger at edge. Writing any of these two information gives you 1 mark. So flies off at edge first. আচ্ছা, এটা হচ্ছে তাদের এক্সপ্লেনেশন। Examiners report কি লিখছে? The majority of candidates did think that the mud at the edge of the plate would leave first. However, comparatively few could give us the satisfactory explanation. Some assumed a constant centripetal force and a frictional force that becomes smaller as the disk speeds up. Some assumed a constant centripetal force and a frictional force that becomes smaller as the disk speeds up. So some people assume that the centripetal force would remain constant, but the frictional force would become weak, which is absolutely wrong. Others thought that it is the centripetal force which holds the mud in place, which is also wrong. Centripetal force is actually something else. It is wrong. It was common to find an explanation which did not include either friction or the centripetal force. So many people did not even bother to write about this force, just went on to write answers in other wordings. Answers such as at the edge, because the force will not hold the mud in place, were seen frequently. Because the force will not hold the mud in place. Okay. This might as well be the force of from the Star Wars. The force will not hold the mud in place. Maybe, I don't know. But anyway, these are the wrong answers. So if I was answering this question, how would I write this? I might write this in this way. Because I always prefer to write answers in with equations. I'm going to write F equals to m omega square r. So centripetal force is largest at the close to the border. So mud at the border will max out the frictional force earlier than the mud at the center and fly off. Now, this is a wrong set of wording. I would say, so the mud at the border will fly off early because the frictional force will not be enough to keep the mud in place. Yeah, that sounds like a good wording. I'll say it again. You don't have to write this. Just try to understand what I'm saying. F equals to m omega square. So centripetal force is biggest at the border. Full stop. So mud at the border will fly off first because frictional force will be surpassed earlier for the mud at the border. বুঝা গেছে কি বলছি?
G, sir.
So question number 8 actually pretty simple. এখানে খুব difficult কিছু নাই, এটা তোমরা try করলে more or less পারবা। তারপরের প্রবলেমটাও more or less similar problem. Let's go for number 10 where we have a bit of a graph. Yep. Number 10. Let's have a look. Define gravitational potential at a point. It's a 2-mark definition, so it's important that you write the definition properly. I might write the definition like this: the amount of work needed to do the amount of work needed to done / energy need to be spent to bring unit mass from infinite distance to any point within a gravitational field is the gravitational potential of that point. I'll say it again slowly. The amount of work needs to be done, or you might like write the amount of energy needed to move. দুটো যে কোনোটা লিখলে হবে, তুমি স্ল্যাশ দিয়ে দুটো লিখতে পারো, যে কোনোটা লিখলে হবে। I'll say it again. The amount of work needs to be done to move unit mass from infinite distance to a point within a gravitational field is the gravitational potential of that point. Here it says that the Earth may be considered to be an isolated sphere of radius r with its mass concentrated at its center. The variation of the gravitational potential phi with distance x from the center of the Earth is shown in figure 1.1. So we have the gravitational potential on the y-axis and the distance from the planet is on the x-axis. We are only given the graph up to the surface. This graph is not an actual distance measurement. This is in terms of the radius. So r, 2r, 3r, 4r, 5r, like that. And it says the radius of the Earth is 6.4 × 10⁶ meter. They have given the r value over here. By considering the gravitational potential at the Earth's surface, determine a value for the mass of the Earth. So this is easily doable because we know that phi is given by phi equals to minus gm by r. So if we pick up a value at r, the value at r, if I just zoom in on this graph, I might as well say this is at the halfway point between these two lines. And here you can see this is 2. So each small division is 0.2. So this would be 6. This is 6.2. This is 6.3. বললাম তোমাকে বুঝতেছো কেন 6.3 হচ্ছে? Might as well choose a bit smaller thickness. So I'm considering this is the crossing point. So it's 1.5 division. So 6.4, 6.2, 7. So this is 6.3. So শুধু 6.3 না, তার সাথে অবশ্যই আমাদের এই ভ্যারিয়েবলটাকে অ্যাড করতে হবে। So let's consider that as well. So minus 6.3 into 10 to the power 7 equals to minus 6.67 10 to the power minus 31 into m into 6.4 to 10 to the power 6. এটা বসাবা, বসালে এখান থেকে ম্যাথটা বের হয়ে আসবে। Well and good. Then number 2, it says a meteorite is at rest at infinity. The meteorite travels from infinity towards the Earth. Calculate the speed of the meteorite when it is at a distance of 2r above the Earth's surface. Explain your working. Acha. Bujo. A meteorite is at rest at infinity. So, a position potential value koto? Someone tell me. What is the value of potential at infinite distance?
0.
It is 0. Beautiful. So it is starting from its journey from a zero distance, and then it travels. We are asked to calculate the speed of the meteorite when it is at a distance of 2r above the Earth's surface. Now, this is the important bit that you have to read with very high careful. Have a look. What does this sentence read? It is at a distance 2r above the Earth's surface. Read again. It is at a distance 2r above the Earth's surface. So what is the actual distance from the center? 3r. So you have to take the reading from the graph for 3R, not for 2R. These are the small traps that the examiner set for you. And I'm warning you not to get into these traps. Read the question very carefully. So we are trying to take a read off for this point's potential, which is somewhere over here. It's a bit of a fraction. So I might as well use for this point minus 2.1. So the amount of work done would be, they're asking us to find out the speed. So I'm going to write half mv square, that is the kinetic energy, equals to m multiplied by 0 minus how much did we get? Minus 2.1 into 10 to the power 7. এখানে m আর m crosses out, so ultimately you're gonna get the value of v. দেখো তো v টা কত আসে? Help me. Root over of 4.2 10 to the power 7. 6.48 kilometers per second. আচ্ছা, 6.48 into 10 to the power
6.5 into 10 to the power 3.
You could write this in 6.6480, ওটাও হয়, but I always prefer large numbers to be expressed in standard form. That's why I always tend to give in this expression. This is convenient. I feel convenient with this, and examiners also like to see large numbers to be expressed in standard form. So if you build up a habit for that, is good. I actually shouldn't talk about habit building up at A2 level, but I'm still saying because you should know what is good and what is not. It's all about how the examiners like it. I mean, it's very simple. I mean, let's say you want to eat a burger. You could go to a grocery shop, buy all the individual item, come to your home, cook it off, and take and spend some just a half an hour, 40 minutes time to prepare it, and have some sweat coming down your cheeks and everything, and then you can have the burger. Or you can just go into a shop, a good burger shop, drop the money and have it. So usually we like the second one, usually. But if you're looking for some gourmet burger that you want to make by yourself, which is not available in a shop, because it is not available in a shop, you might consider making it. So if you provide the answer in the way that the examiners like it, the examiners will like it, and that's preferably what we're trying to achieve here. Number 3, in practice, the Earth is not an isolated sphere because it is orbited by the moon, as illustrated in figure 1.2. Okay. The initial path of the meteorite is also shown. So the meteorite is coming this way, Earth is here, moon is here. So there's two changes of the motion. So there's two changes to the motion of the meteorite caused by the moon. So what are the two likely changes? Now, first of all, because this question is including the existence of the moon within our discussion, this essentially means that the Earth will pull the meteorite, the moon will also pull the meteorite, which means now you have two bodies pulling the meteorite from the infinite distance towards the Earth, which means whatever the value of speed that we calculate over here, if we consider the existence of moon, because of the additional pull or additional gravitational force, the actual speed would be more, because now we have to consider that this meteorite is being pulled by both the Earth and the moon. So the speed of the meteorite would be higher, and then the trajectory of the meteorite, or the direction of the velocity of the meteorite, should not be exactly towards the center of Earth, because wherever the moon is located, the moon is going to try to deviate it. So I cannot essentially say in which direction is going to deviate. I can only, I cannot say the exact direction where the meteor is going to head, but I can say it for sure that it's definitely not going to aim directly to the moon, because Earth is there. Earth is going to make its own pull, and it's definitely going to aim directly towards that, or towards the center of that, because the moon is going to deflect that pathway. So I'm going to write for the second change that the direction of velocity for the meteorite is not going to aim exactly towards the center of the Earth, because the gravitational force of moon is going to cause some deviation. We're gonna have a look at the mark scheme to consider the answer of this question. This is 10, question number 10, last part 3. Okay, here we are. Example. So examples are always good mark schemes because this means that you can write your answer in a whole lot of different variation ways. These are just some suggestions how the answer could be written. Speed or velocity or acceleration should be greater. Deviates or bends from the straight path. Any sensible ideas? 1 each, maximum 2. If you have a look at the examiner's report, the majority of candidates realized that the path of the meteorite would be bent, but a surprising number thought that the speed would reduce. A significant number lost marks due to vague responses that suggested merely a change in speed would take place. Okay, you cannot simply write there be a change in speed. You have to specify what kind of speed change should be there. Makes sense. Makes sense to me, but does it make sense to the rest of you?
Sir, Gravity to straight with the record, Earth to move, Earth couldn't faster change.
Oh, what this essentially means, I get your question. If the moon did not exist, then the path is supposed to be a perfect straight line because we are considering the whole system once again to be an isolated system. So we have the Earth. At infinite distance, there is a meteorite. Meteorite is pulled towards Earth by the exclusive gravitational field of the Earth itself. So if that happened, the meteorite would come straight towards the center of Earth. Compared to that, if the moon is present, what would have happened? Actually, to meteorite track realistic meteorite track to perfectly straight line. It always goes around in curve because it is affected by the Earth, Moon, Jupiter, Saturn, the Sun, all the other stuffs around. But if you consider between two isolated cases, then what should have happened? What would be the difference in the case where moon is there compared to the case where moon is not there? That's the scope of your question. Did I answer your question?
Yes, sir.
Beautiful. মানে এই প্রবলেমগুলো সলভ করার জন্য আমাদেরকে আইসোলেটেডলি একটা সার্টেন সিনারিও ভিজুয়ালাইজ করতে পারতে হবে। মানে এটা কি কৃত্রিম ভাবে ইংলিশ মানে কি সিনথেটিক একটা সিচুয়েশন জাজ করতে হবে বা ভিজুয়ালাইজ করতে হবে যে যেখানে এই দুটো অবজেক্ট নিয়ে আমরা মাথা ব্যথা করতেছি, আশেপাশে আর কিছু নাই। কারণ দ্যাটস হাউ উই সিম্পলিফাই আ সার্টেন প্রবলেম সলভিং প্রসেস। আচ্ছা, এরপর দেখি নাম্বার 11। নাম্বার 11 অ্যাকচুয়ালি আমাদের চার্জ পার্টিকলস বা চ্যাপ্টার 4 ওয়ার্কশিট 4 সলভ করার পর পড়া যাবে, কারণ হচ্ছে এখানে আমাদেরকে কম্পেয়ার করতে বলছে যে গ্র্যাভিটেশনাল ফিল্ড আর গ্র্যাভিটেশনাল ফোর্স ইলেকট্রিক ফিল্ডের মধ্যে সিমিলারিটি। এটা আপাতত সলভ না করলে হবে, স্কিপ করতে পারো। বুঝি নাই
11A চ্যাপ্টার প্রবলেম।
আচ্ছা হ্যাঁ, 11A টু A চ্যাপ্টার, বাট বি নাম্বার হচ্ছে ডিফারেন্সেস। সো যতটুকু পারো ততটুকু লিখতে পারো, নো প্রবলেম দেয়ার।
আমি লিখতে চাচ্ছিলাম যে mass is considered to be located at the center of the center concentrated on if two marks greater than
আচ্ছা, আমি জারিফের ভয়েস অনেক ভাঙা শুনতেছি। ইজ ইট অনলি মি অর ইজ ইট সেম ফর, I mean, is it my internet connection that is poor or I'm not sure. জারিফ তুমি আস্তে আস্তে আরেকবার বলো, কারণ পুরোটুকু লিখতে অনেক সময় লাগবে। আস্তে আস্তে আরেকবার বলো, অথবা একটা কাজ করো, হোল্ড আপ, send me a voice message personally into the messenger by pressing down the microphone button. That can help better, I think. তাই না? হ্যাঁ। জারিফ তুমি কি আমাকে ভয়েস মেসেজ পাঠাচ্ছ?
স্যার চ্যাটে পাঠাচ্ছি।
চ্যাটেও রেকর্ড পাঠানো যায়?
ভয়েস রেকর্ড
মানে আমি বলছিলাম যে তুমি যদি মেসেঞ্জারে ভয়েস রেকর্ড করে পাঠাতে তাহলে তোমার টাইপ করতে হতো না। It might have saved some time. I mean, just directly send me a message in the messenger with the microphone button pressed so that you don't have to write the whole thing. I mean, that could save time. That's what I'm saying. If it's a small question, you can always write in the chat window, no big deal. But I sense that Zarif was asking a elaborate question, so I could not hear it right. I think my internet connection is, maybe, I'm not sure. Mm.
So general plus.
Oh, sure. For even A2, can I write that the mass of the planet is considered to be considered the center of the planet? Well, that is the typical way that we consider uh, I mean, that is basically, I mean, what you have mentioned is actually elaborating the idea of point masses. I mean, this is basically what we mean by the word point mass, that we have a particle which has measurable mass but zero volume. This is not wrong, but the reason they did not actually or they do not usually provide this as an acceptable answer for this type of questions is because they want you to write this answer in terms of the gravitational field. The thing that I told you earlier, that if a spherical mass, not if, a spherical mass and a point mass with the same amount of mass, beyond the radius of the surface of the sphere, the shape of the gravitational field or the gravitational field strength, the variation of the gravitational potential towards the infinite distance, they both produce identical gravitational field. A point mass and a spherical mass beyond the border of the sphere produces identical gravitational field. This is usually the type of expression that the examiners appreciate. I think that, what does the mark scheme say for this question? এরকম কিছু বলছে? Separation mass greater than radius or diameter or sun or planet. Okay. 11.8.2. Candidates should realize that the universal gravitation applies because the diameters of the planet and sun are very much less than the distance between them. That's it. Okay, that's a bummer. This is actually correct. But it didn't pop in my head in the first go, but this actually makes sense. Zarif, what you wrote is correct, but examiners are looking for this. Like I said, I think it's sort of similar to the burger example. What you wrote is not incorrect. It's perfectly all right, but this is not what the examiners are looking for. Breaks my heart, but that's the way it is. But I should ask you, does this sentence make sense?
Sir.
Acha, এটা star mark করে রাখো, because you didn't think of this point, which means you have to revise this question. You should revise this question every once in a while whenever you go through this worksheet, so that you actually can remember that, okay, this is that point. I'd do that if I was solving this paper for my A levels. Marking my mistakes is always a very good thing. 12 and 13 are also quite simple. 13 এখানে তোমাদের থার্মাল চ্যাপ্টার একটা কোশ্চেন আছে, এটা আপাতত করা লাগবে না, কারণ থার্মাল চ্যাপ্টার তোমাদের এখনো পড়াই নাই. You or maybe you do not know what these properties mean and not know how to work with this problem, so you can skip the questions which are not from your taught topics, and they're going to be eventually filled up whenever we do those chapters. So you can rest assured that you don't have to bother for those for the time being, at least. 17 seems like a good question. Let's have a try for this one. Have a look. Number 17. আমি তোমাদের রিকোয়েস্ট ছাড়াই যারা ওয়ার্কশিট বানায় তারা ওয়ার্কশিট অ্যাটেন্ড করে আমি তোমাদেরকে বেছে বেছে কিছু প্রবলেম সলভ করাচ্ছি যে প্রবলেমগুলো আই ফিল লাইক যে দে ডিজার্ভ সাম সর্ট অফ অ্যাটেনশন তোমাদের কি আরো সমস্যা হচ্ছে বুঝতে বলবান it might feel a bit boring but I wanted to solve this worksheet in today's class. If you have queries please ask me. I'm all for questions. So 17 dekhi. A rocket is launched from the surface of the earth. Figure 4.1 gives data for the speed of the rocket at two heights above the earth's surface after the rocket engines has been switched off. So at this side we have this speed and then at this side this was this speed. So and the mass was kept constant for both of these heights. What I need you to see that whenever the rocket was at a closer height 90.9 into 10 to the 6 it had a higher speed. As the rocket moved further away then it has a lower speed, which means basically it is converting its kinetic energy to gravitational potential energy to slowly get away from the earth. The earth may be assumed to be a uniform sphere of radius r equals to 6.3 × 10⁶ meter with its mass m concentrated at its center. The rocket after the engine has been switched off has mass m. Write down an expression in terms of gm, m, h1, h2 and r for the changing gravitational air potential energy of the rocket. আচ্ছা এই কোশ্চেনটা লেখা একটু চ্যালেঞ্জিং হতে পারে. What I need you to understand that rocket is launched from the surface of the earth. So rocket basically moved from a closer height to a further height. So this is your final position and this is your initial position. These two values are heights from the surface. So if you are trying to get the distance from the center, এই দুইটা ভ্যালুর সাথেই রেডিয়াস কে অ্যাড করতে হবে. So I might write this expression in this manner. G M no m into delta phi, so that brings m minus that's the expression I would write. If you want to make it a little bit posh or just a bit more what can I say, edible for the examiners, you might as well make it a bit more aesthetically pleasing. GMM and then write 1 upon r plus h1 minus 1 upon r plus h2. So that would be a better looking version, but if you write this much, it's perfect all right as well. This is also okay. Half m আচ্ছা এখানে বলছে using the expressions in a determine a value for the mass m of the earth. এইটা করতে গেলে কি আমি ঝামেলা পড়বো? আচ্ছা করে দেখি. আচ্ছা এই জিনিসটা ভ্যালু কি আসবে, পজিটিভ আসবে না নেগেটিভ আসবে? না, আমি চিন্তা করতেছি যে আমার ক্যালকুলেশনে মাইনাস আসতে পারে কিনা সেটা নিয়ে একটু বদার করতেছি। এখানে আর প্লাস এইচ ওয়ানটা হচ্ছে ছোট, আর প্লাস এইচ টুটা হচ্ছে বড়, তাহলে এই ফ্যাকশনের ভ্যালু আসবে পজিটিভ, তাহলে এটাও পজিটিভ আসার কথা। এটা আসবে নেগেটিভ কারণ আমি ভি টুটা আগে লিখছি। আচ্ছা, এটা কেন? কারণ হচ্ছে আমাদের গ্র্যাভিটেশনাল পোটেনশিয়াল এনার্জি বাড়তেছে এবং কাইনেটিক এনার্জি কমে যাচ্ছে। সো total energy is constant, which means delta EP equals to minus delta EK. আচ্ছা আচ্ছা, might as well flip it over here, it doesn't matter. আমি এখানে ইচ্ছে করে ফ্লিপ করতেছি কারণ আমার আনসারটা যাতে নেগেটিভ না আসে, বাট তোমার যদি ফাইনাল আনসার নেগেটিভ পাও, you don't have to bother, disregard the minus sign. You can just write the answer over here as positive, which is gonna be perfectly all right. And then over here we should write 2 into then 1 by এই না বলবান কষ্ট করে এটা একটু তোমাদের ন্যাচারাল ডিসপ্লে ক্যালকুলেটরে লেখো, লিখে ভ্যালু বের করো, ভ্যালু বের করে একটু ওয়েট করো, আমি এই 4-5 মিনিট পর আবার আসতেছি। I'm taking a small break.
Answer part 43.
মিলছে? দাঁড়াও, কত নাম্বার ছিল এটা? এটা হচ্ছে 17। 6.00 10^24। এরকম আসছে?
Yes, sir.
00
না স্যার, বেশি আসছে এটাতে।
মানে 6 এর পর ডিজিট আসছে?
Yes, sir. 6 এর পর করে ডিজিট আসছে।
কেন ডিজিট আসছে? আচ্ছা, আমি তো ভুল ভুল লিখছি এখানে। I've been doing it for 31 for so long. Why did I try at 31? I'm so sorry. I'm extremely sorry. This was not supposed to be 31. এটা হচ্ছে 11. কিন্তু 11 এর জন্য তো আমাদের 10 এর পাওয়ার ভ্যারি করার কথা, এটা তো ভ্যারি করার কথা না। এটা পারফেক্টলি ম্যাচ করার কথা তো আনসার। আমি পুরোটা করবো আবার? আমি তো পুরোটা করতে চাই না। আচ্ছা করি। (6.38 10^6 plus 19.9 10^6 inverse 1 minus bracket 6.38 10^6 plus 22.7 10^6 bracket inverse into 2 into 6.67 10 to the power minus 11 equals to at the okay bracket 5370 square minus 5090 square bracket divided by answer 5.99 into 10 to the power 24 আসছে আমার 5.9923 I'm getting 5.9923 into 10 to the power 24. আচ্ছা, এদের আনসার হচ্ছে কত? 6.00. 6.00. If equation A is dimensional sound 03, the dimension is sound but incorrect, treat as ECF. আচ্ছা, treat as ECF করলে আমাদেরকে এটা একটু ভুল হলেও ফুল মার্কস দিবে।
dimensionally unsound বলতে কি বোঝাচ্ছে?
ডাইমেনশনালি আনসার মানে হচ্ছে যে এই এক্সপ্রেশনটা লিখতে যদি কেউ ভুল করে এবং হচ্ছে মানে আলটিমেটলি মনে করো এখানে বোথ সাইডের ইকুয়েশনের যে ডাইমেনশন মিন্স বেসিক্যালি মিন্স দ্যাট, এটা আমি কেমনে বুঝাই, the base units on both sides should be same. That's what is meant by dimensionally equal. So এখানে বেসিক্যালি আমরা কি পাচ্ছি? এখানে পাচ্ছি হচ্ছে ম্যাথ আর ম্যাথ কাটা চলে গেছে, সো আলটিমেটলি উই আর গেটিং v স্কয়ার মাইনাস v স্কয়ার, তার মানে এটা হচ্ছে মিটার পার সেকেন্ড স্কয়ার। বেসিক্যালি এটা ডাইরেক্ট সাইডের ইউনিট হচ্ছে মিটার পার সেকেন্ড স্কয়ার। এখান থেকে তুমি যদি জাজ করো, এখান থেকে তুমি পাবা হচ্ছে জিএম, জি এর ইউনিট হচ্ছে নিউটন কেজি স্কয়ার পার মিটার স্কয়ার, এফডি জি ইকুয়ালস টু হ্যাঁ নিউটন কেজি স্কয়ার পার মিটার স্কয়ার। সো এখান থেকে নিউটন মিটার স্কয়ার পার কেজি স্কয়ার। সো এখান থেকে একটা কেজি চলে যাবে আর ম্যাস আর ম্যাস মাল্টিপ্লাই করে মিটার পার সেকেন্ড স্কয়ার থাকতেছে, কারণ এখানে নিউটন থেকে 8টা কেজি চলে যাবে। ডাইমেনশনাল আনসার মানে হচ্ছে এই দুটো ইকুয়েশন লিখতে যদি কেউ ভুল করে সেই কেসে এই জিনিসটা দিবে না। আচ্ছা, এখানে একটা v1 v2 স্কয়ার দিয়ে একটা জিনিস আছে, হাফ ইনটু v1 v2 v1 minus v1 স্কয়ার minus v2 স্কয়ার। So they did the big minus small. A similar problem as regard to mathematical ability arose here. Many candidates gave an incorrect answer as to a result failed to answer the basic mathematics. For example, v1 square minus v2 square was assumed to be equal to v1 minus v2 whole square. এটা তো একটা বেসিক মিস্টেক, মানে বলদামি মিস্টেক। But they wrote this one as v1 square minus v2 square. So they basically did big minus small. They didn't do final minus initial. I think that works out, কারণ আলটিমেটলি আমরা ভ্যালু বসানোর সময় বিগ মাইনাস স্মলই করতে হয়েছে। এখানে আনসারটা পারফেক্টলি ম্যাচ করতেছে না, আমি তো পুরোটা হুবহু বসাইলাম, 6.67ই বসাইছি। ওরা কি 6.7 দিয়ে করছে? 6.67 দিয়ে করছে। 26.6 26.28 26.28 কি হয়ে পাইছে? 26.28 পাইছে হচ্ছে 6.3 প্লাস 19.9 26.28। হ্যাঁ, এখানে পাচ্ছে হচ্ছে 22.7 23.08 sorry 29.08 29.08 20/6 inverse 1. I don't know why their answer is significantly different than mine. What I think I did the whole calculation using the answer of the question, but within this part they actually wrote in between value for the calculation. So m into a certain number equals to certain number. I believe that they did some approximation while they wrote these two numbers. Some numbers were skipped off. That's why ultimately their fraction value gave them perfectly 6.00, whereas I used the whole calculator value and I got 5.9929. So if I was doing this math, I'm going to write this whole thing over here with kg unit, and right over here I'm going to only write 5.99 into 10 to the power 24. And I believe the examiner should still give me full marks because this is not a wrong answer. বুঝছো কি বলছি? সো ওই সেকেন্ড লাইনে তারা কিছু রাউন্ড অফ করছে বলে ওই ঝামেলাটা হয়েছে। আচ্ছা, আমি এই প্রবলেমটা খুব ভালো মতন করাবো। কোশ্চেন নাম্বার 18, কোশ্চেন নাম্বার 18টা আমরা একটু দেখি। Explain what is meant by radian. এখানে radian এর ডেফিনিশন লিখবা। Why one complete revolution is equivalent to up to an angular distance of 2 pi radian. What is the answer of this? Because the circumference of the circle is 2 pi r. Is that the answer? Yes. Arc equals to r theta, and for one revolution arc equals to 2 r theta. 2 pi r, yeah, that's the answer. The circumference of the whole circle is 2 pi r. So total angle subtended at the center by the whole circumference is 2 pi r divided by r, which is 2 pi. Bah, beautiful. My assumption was correct. Nice, feels good. আচ্ছা, বি নাম্বার কোশ্চেনটা আমরা একটু ভালো করে খেয়াল করি। এখানে আমাদের তো একটা ইলাস্টিক স্ট্রিং নিয়ে কাজ করতে হচ্ছে, সো এই কোশ্চেনটা একটু ভালো করে খেয়াল করো যে কি হইতেছে এখানে। হ্যাভ আ লুক। An elastic cord has an unextended length of 13.0 centimeter. One end of the cord is attached to a fixed point C. A small mass of weight 5.0 Newton is hung from the free end of the cord. The cord extends to a length of 14.8 centimeter as shown in figure 1.1. Try to understand. This is the scenario that unextended length is 13 centimeter. Whenever we have attached a fixed mass and this is not rotating yet, the total length of the string is now 14.8 centimeter, which means we now have an extension of 1.8 centimeter because of the weight of the small mass. The cord and mass are now made to rotate at a constant angular speed omega in a vertical plane about point C. When the cord is vertical and above C, its length is the unextended length of 13.0 centimeter as shown in figure 1.2. This is the important bit. So we are making a circular rotation at such exact speed that when the mass is vertically above the center of the rotation point, perfectly above this point, then its length is the unextended. So at this point, the tension of the rope is 0 because it is not extended anymore. The exit centripetal force exactly over here is only the weight of the mass, because the unextended length of the cord is 13 centimeter. At the highest position, right above the center of the circular motion, the string has become unextended for that exit instant. However, whenever this will go down, this will be definitely longer, so that is mentioned as L. L নিয়ে আমরা পরে ম্যাথ করব, but exactly at this position, the only vertically downward force that this mass is experiencing is its own weight, and that exclusive weight is going to provide the centripetal force required for this exact position. This is the important bit. The question goes further, so that the angular speed omega of the cord of the mass is 8.7 radians per second. This is pretty simple. We can go it for the top position. So you can choose to write for the top position, or you can choose not to write. I'm going to write centripetal force equals to weight. So this is going to give me m omega square r equals to mg. M and m crosses out. So omega square into radius হচ্ছে 13 centimeter, so it is 0.13 equals to 9.81. এখান থেকে ওমেগা বের করে দেখো কত আসে। I'm going to do it. Hi. Oh, no.
8.7.
মিলে মিলছে মিলছে তাসি তো মেসেজ দেখছি 5.99 আসছিল। আচ্ছা, 2তে বলছে the cord and the mass rotate so that the cord is vertically below C as shown in figure 1.3. Calculate the length L of the cord assuming it obeys Hooke's law. So এই পজিশনে আমাদের length কত হবে? এখন একটা জিনিস বুঝো, this length at this position is working as the radius of the circular motion for this point. Actually আমাদের পুরো অবজেক্টের মোশনটা হবে খানিকটা elliptical বা ডিমের মতো। নিচের দিকে থাকবে বড় রেডিয়াস, উপরের দিকে থাকবে ছোট রেডিয়াস, কারণ এটা একটা ইলাস্টিক স্ট্রিং। এই পজিশনের রেডিয়াস হচ্ছে 13.0, whereas এই পজিশনের ডিসটেন্সটা কত সেটা আমরা বাই জানি না, সেটা আমরা ক্যালকুলেট করে বাই করব। সো এই পজিশনের লেন্থটা হচ্ছে L। এখন what we need to judge that at this position of the mass, I'm drawing the mass right over here to draw the force scenarios. What are the forces involved over here? You have to understand the centripetal force should work towards the center, which is m omega square r. This is the resultant force. This resultant force should come by the effect of two different forces. One is the tension of the string, and the other one is weight working downwards. এই ছবিটা তোমাদের আঁকা লাগবে না, বাট আমি এটা আঁকতেছি তোমাদেরকে বোঝানোর জন্য, which means the resultant force, which is definitely the centripetal force, is made available from T minus W. Tension of the string minus the weight gives you this thing. So এই কোশ্চেনটাকে নিয়ে আমাদের আস্তে আস্তে আগাইতে হবে। সো আমি এখানে লেখা শুরু করি। that FC equals to T minus W, which gives us M omega square R equals to spring constant. Tension হবে হচ্ছে kx, spring constant into extension. So k, whatever that k is, I'm going to write the value of k after a while. একটু খেয়াল করো, k into L, আচ্ছা আমি x ই লিখি আপাতত, kx, this is the Hooke's law, minus mg. এই পর্যন্ত বুঝছো কিনা দেখো। This is for the lowest point. এখন আমরা আস্তে আস্তে এই জিনিসগুলোকে মানুষ করা শুরু করবো। মানুষ করা শুরু করবো মানে হচ্ছে আমরা আস্তে আস্তে ভ্যারিয়েবল গুলাকে রিপ্লেস করব। এম এর মতো থাকুক, কারণ এখানে নিউমেরিক্যাল ভ্যালু বসাচ্ছি না। ওমেগা স্কয়ার আর, আচ্ছা কেটা হচ্ছে স্প্রিং কনস্ট্যান্ট, কে ভ্যালু আসবে হচ্ছে এই সিচুয়েশন থেকে। এখানে আমাদের অবজেক্টের ওয়েট ছিল হচ্ছে এমজি আর আপার পুল ছিল হচ্ছে এফ। সো আমি যদি এখানে হিসাব করি এফ ইকুয়ালস টু এমজি, হুইচ মিন্স কে এক্স ইকুয়ালস টু এমজি। সো এখান থেকে আমি কে ভ্যালু পাবো হচ্ছে এমজি ডিভাইড বাই 0.018। 0.018 কেন? কারণ এ দেখো আমাদের এই লেন্থের জন্য আমাদের এটা হচ্ছে ফুল লেন্থ, whereas the original length of the string was 13 সেন্টিমিটার। তাহলে এখানকার এক্সটেনশন কত? সাবট্রাকশন করলে 1.8 সেন্টিমিটার আসবে, আসবে কিনা বুঝতেছো? এইটা কিন্তু এই এক্স না, এই এক্স হচ্ছে এই পজিশনের এক্স, এটা হচ্ছে স্টেশনারি পজিশনের এক্স। সো এল এর এই এল কিন্তু 14.8 না, এল হচ্ছে রোটেশন চলতেছে ওই সময়কার লেন্থটা হচ্ছে এল। সো এখানে কে এর ভ্যালু হিসেবে লিখতে পারি হচ্ছে mg ডিভাইডেড বাই 0.018, আর এই সিচুয়েশনের এক্সটেনশনটা হবে হচ্ছে this is the full length of the string right now, the original length of the string was 13.0 centimeter। তাহলে এই সিনারিওর জন্য এক্সটেনশনের ভ্যালু হচ্ছে l minus 0.13। এটা হচ্ছে এই সিচুয়েশনের জন্য স্ট্রিং এর এক্সটেনশন। So might as well remove this pencil mark vertical line. The reason I'm writing this expression with variables t8 because I want to get rid of the m value, কারণ পুরো কোশ্চেনে কোথাও আমাদের স্মল ম্যাথটার ম্যাথ দেওয়া নাই। দেখো কোথাও কিন্তু স্মল ম্যাথের ভ্যালু দেওয়া নাই, আছে? In the entire question they did not give us the value of the small m, which means somehow you have to get rid of the m value from the question, from the equation. So m বাদ, আলটিমেটলি আমার এই ইকুয়েশন থেকে l বাই করতে হবে। এখন এখানে একটা জিনিস খেয়াল করো, এখানে যে m ওমেগা স্কয়ার r লিখছিলাম, এই রেডিয়াসটা হচ্ছে this radius, this r over here is the radius of this length, which is basically l. So I'm now going to start replacing values over here. Omega square was calculated to be 8.7. এটার অ্যাকচুয়াল ভ্যালু 8.7 এর পরের ডিজিট কি কি ছিল বলো তো আমাকে? কারো আনসার আছে এটা? 8.7 ওয়াট? আচ্ছা আমি করি।
8.68686।
আচ্ছা এটাকে 8 তাহলে 8.69 হয়, তাই তো? 8.6,
Yes sir।
আচ্ছা 8.687 লিখি, 8.687. I'm going to use this number for my omega square over here, not exactly 8%, but if you want you can also use 8%. আচ্ছা কোশ্চেনে তো আমাদের অলরেডি 8.7 বলে দিছিল, তাই না? আচ্ছা 8.7 দিয়ে করে দেখি কি হয়। So let's say 8.7 squared multiplied by L equals to 9.81 divided by 0.018 multiplied by L minus 0.13 minus 9.81. এটুকু হচ্ছে তোমার বেসিক এল এর ইকুয়েশন। এখন এটাকে সামহাও হাতাপিতা করে টরে এল এর ভ্যালু বাই করতে হবে। করো, এল এর ভ্যালু বাই করো।
Third,
জি বাবা।
17.2 centimeters.
70.2 সেন্টিমিটার আসছে না?
জি স্যার।
দেখি মিলছে কিনা, মিলা উচিত, না মিললে তো আরেক কষ্ট। এটা হচ্ছে 18, ওই 70.2। আচ্ছা, আনসার মিলছে, ভালো কথা। বাট এই ক্যালকুলেশনের স্টেপস গুলো বুঝা গেছে কিনা? এভরি সিঙ্গেল পার্ট হ্যাড সাম সিগনিফিক্যান্ট নিউমেরিক্যাল কনভার্সন ওভার হিয়ার। আমি এই পুরো জিনিসটা আরেকবার একটু ভালো করে বলতেছি, খেয়াল করো। এফসি ইজ এম ওমেগা স্কয়ার আর, ওমেগা ভ্যালু আগে বের করছি, বাট এখানকার আরটা হচ্ছে অ্যাকচুয়ালি এখানকার এল, যেটা আমরা পরে এখানে বসাইছি। Point 1, tension is coming from the Hooke's law, which is F equals to kx, or tension equals to kx. K is the spring constant. A spring constant আসছে হচ্ছে এই expression থেকে, which was given for the stationary scenario, and the x in this case is the actual extension of the string for this scenario, which is the full length minus the unextended length. This is this much. So ওই এক্সপ্রেশনটা এখানে x এর জন্য বসছে। এই দুইটা জিনিস দুইটাই কেয়ারফুলি ডিল করতে হবে। এখানে আমাদের এল ইনভলভ আছে, এখানেও এল ইনভলভ আছে। সো আলটিমেটলি পরে ক্যালকুলেশন করে এটা আসবে। আমি এটা করছি কারণ হচ্ছে আই কুড সি ওয়ার্ক দ্যাট ওয়ে, বাট ইফ ইউ নিড মোর লাইন্স টু রাইট, বি মাই গেস্ট এন্ড রাইট মোর লাইন্স, নো প্রবলেম। বাট ইফ ইউর ক্যালকুলেশনস আর কারেক্ট, ইউ শুড এট দি এন্ড আপ উইথ দিস রেজাল্ট। কনভার্সন গুলো বুঝা গেছে কিনা বলবান? আচ্ছা, এরপর
Nineteen.
19 এর
C.
suggest two factors that could in case of a real planet cause variation in the acceleration of free fall at its surface. আচ্ছা, একটা সিচুয়েশন হচ্ছে the surface of the planet could, I mean, the planet might not be a perfectly uniform sphere. এটা তো বুঝো, কোথাও পাহাড় থাকবে, কোথাও নিচু থাকবে। সো ওই সকল ডিফারেন্ট ডিফারেন্ট জায়গাতে we can have different values. এটা হচ্ছে একটা রিজন। আর two factors that could cause variation in the acceleration of the free fall at its surface, এটা একটা রিজন। আর আরেকটা রিজন হচ্ছে if you come to think about it, the planet might not be perfectly spherical. For example, পৃথিবী যেরকম হচ্ছে কমলা লেবুর ন্যায় চ্যাপ্টা, সো নর্থ সাউথ একটু চাপা, সেটা একটা হইতে পারে, বাট ওটাও তো সারফেসের প্রপার্টি হয়ে গেল। আচ্ছা, the other reason can be that the axial rotation of the planet actually causes the same mass object to exert different amount of force on its surface. কারণ এখানে এখানে আমাদের যে এক্সপ্রেশন গুলো আসছে, আমি যদি এখানকার এক্সপ্রেশনটা লিখি তাহলে জিনিসটা একটু ক্লিয়ার হবে। আমি এ নাম্বারটা করতেছি। কোশ্চেন নাম্বার এর আইডিয়াটা হচ্ছে যে একটা প্ল্যানেটের গায়ে এখানে ইকুয়েটরে একটা ম্যাস আছে। সো এই ম্যাসটা আলটিমেটলি কতটুকু নরমাল গ্র্যাভিটেশনাল ফোর্স অ্যাপ্লাই করবে, সেখানে আমাদের গ্র্যাভিটেশনাল ফোর্স এক্সপ্রেশন হচ্ছে gmm ডিভাইড বাই r স্কয়ার। রিকোয়ার্ড সেন্ট্রিপিটাল ফোর্সের ভ্যালু হচ্ছে m ওমেগা স্কয়ার r। সো এইটুকু অ্যাভেলেবল ফোর্স থেকে সে এইটুকু ফোর্স অলরেডি ইউজ করে সেন্ট্রিপিটাল সার্কুলার মোশন মেইনটেইন করবে। সো আলটিমেটলি গ্রাউন্ডে সে এক্সার্ট করবে এই দুটো ডিফারেন্স, হুইচ ইজ দ্য সাবট্রাকশন gmm ডিভাইড বাই r স্কয়ার্ড মাইনাস m ওমেগা স্কয়ার r। এইটুকু সে অ্যাকচুয়ালি গ্রাউন্ডে অ্যাপ্লাই করবে। এখন এখানে একটা জিনিস যেটা বলছে ওরা ম্যাথে যে explain why the normal radiation force on the mass will have different values at equator and at the poles। এটা কারণ হচ্ছে আমরা যখন পোলে চলে যাব তখন প্র্যাকটিক্যালি এই আরটা হয়ে যাবে 0, because when the farther we go up, the smaller the radius of orbit will become for the mass on the surface. That's why I'm using the word orbit, because it is now going around in circle. It's not axial motion. So at the pole, the radius is the centripetal force requirement will become 0. So it can exert all of its available gravitational force onto the planet. So এটা হচ্ছে একটা রিজন যে আমাদের যত সার্কুলার মোশন হইতে থাকবে তত আমাদের as we go further away from the equator towards the pole, we're going to have a different value of centripetal force. So one of the point that I can think of is the unevenness of the surface, hills and lakes and such things. The other thing can be that the planet might not be perfectly spherical. For example, somewhat like orange or something. These are the 2 points that I can think of to write over here, but I'm not sure what the examiners are expecting. So we're going to have a look at the mark scheme. This is what 19C. Radius of the planet varies, density of the planet not constant, planet spinning, nearby planets or stars, insensible comment, 1 mark each, maximum 2. Acha. The examiners, the most frequently quoted answers included reference to the planet not being spherical and to variation of density of the material of the planet. Some did refer to nearby moons and planets. Acha. Ami ekhane well, this point actually makes sense. Radius of the planet varies, which is basically the shape variation, and they did not say about the hills and stuffs, because I mean, you cannot say about the hills and the lake stuff and the radius of the planet being different in 2 different points, because they both mean the same thing. This basically mean that the actual distance from the center of the planet to the object will actually vary because of the deformity of the planet's shape. So they've only used it as a single point. Radius of the planet varies. This is a single point. The second point says the density of the planet not constant. This actually means, let me just draw something for you. It might, I'll be able to make better sense. Density of the planet not consistent means what? Have a look. If we have a spherical planet, become a sphere. If we have a spherical planet which is of uniform density, then we can consider that its mass is actually concentrated at its center perfectly, because we'd have the same type of gravitational field with inward arrows. So that's going to work just fine. But if that's not the case, if we have a spherical planet where its internal masses have different origins, for example, let's say we have some iron located over this half, whereas we have some gas pockets, natural gas reserve over this half. So let's say this is the iron pit for a planet structure, whereas this is basically gas. In this case, the center of gravity will definitely not at the geometric center. Where would be the center of gravity be located? Close to the heavier mass. So you might as well have this center of gravity of this planet located over here. So because the center of gravity is located over here, if you measure the distance from here to here, you're going to have one distance. If you measure it from here to the other end, you're going to have a different radius, because the distances are actually measured from the center of gravity, because that's basically the point where the gravitational force actually works. So if you have non-uniform density for the planet, you can have the radius factor come in to be different, considering the center of gravity not located at the point that you want it to be located. Does it make sense? এরপরে যে পয়েন্ট আছে প্ল্যানেট ইজ স্পিনিং, এটা একটু আগে বললাম যে স্পিনিং এর জন্য আমাদের ভ্যারিয়েশন করে যেটা উপরের পয়েন্টে ছিল নিয়ারবাই প্ল্যানেটস অফ স্টার, দ্যাটস অলসো অ্যানাদার ফ্যাক্টর. To be honest, nearby planets and stars can make a significant variation because the tides that we have on Earth's surface, the high tide, low tide, those type of tides, these are actually made by the gravitational effect of the moon and the sun together. These two celestial bodies actually attract the total Earth surface, and because the Earth crust, which is the solid Earth or the surface of the Earth, that is a solid object that doesn't undergo deformation, but the water body is liquid, so that can undergo deformation. That's basically what produces the high tides and the low tides. It's dependent upon the position of the sun and the moon, so it works that way. Good discussion. বুঝে গেছে জারিফ? আচ্ছা, নাম্বার 22 তে, আচ্ছা দাঁড়াও, 21 এ এখানে না, 21 তোমরা অ্যাটেম্প করলে হোপফুলি পারবা। নাম্বার 22 তে আমাদেরকে একটা গ্রাফ আঁকতে বলছে। এই গ্রাফটা কেমনে আঁকবা সেটা আমি আলাপ করতেছি, or should we start this graph on the next class? নাম্বার 22 তে অ্যাকচুয়ালি ভালো দুটো কোশ্চেন আছে। এখানে একটা গ্রাফ আছে। নাম্বার 22 আমি নেক্সট ক্লাসে করাবো পুরাটাই।
Okay, sir.
এইগুলাও পারা যাবে। I'm trying to look for a small question, the last for today's class maybe.
স্যার এখন ক্লাস শেষ না?
হ্যাঁ, ক্লাস শেষ করে দিচ্ছি। এখানে আর মানে দেখানোর মতো ছোট কোশ্চেন নাই, বেশিরভাগ কোশ্চেনের বেসিক গুলো আমরা অলরেডি আলাপ করে ফেলছি। নেক্সট ক্লাসে আমি হয়তো এই ওয়ার্কশিট থেকে 2-3টা প্রবলেম দেখাবো, তারপর হচ্ছে আবার সিম্পল হার্মোনিক মোশনের ডিসকাশন কন্টিনিউ করব। সো তোমরা যদি কেউ সিম্পল হার্মোনিক মোশনের ক্লাস লেকচার না দেখে থাকো, মাই আর্নেস্ট রিকোয়েস্ট, ওয়েডনেসডেতে আমাদের ক্লাস হচ্ছে দুপুরে 2টায় না, 2টায় না, 1টায় না, ওয়েডনেসডে 1টার আগে যদি ক্লাস না দেখে থাকো, সিম্পল হার্মোনিক মোশনের ক্লাস না করে থাকো, প্লিজ লেকচারটা একবার দেখবা, যাতে করে আমাদের ফার্দার ক্লাস ফলো আপ করতে সহজ হয়। থ্যাংক ইউ ভেরি মাচ, গুড নাইট, আসসালামু আলাইকুম। আমি একটু পর লেকচার আপলোড করে দিচ্ছি।
ওয়ালাইকুম আসসালাম স্যার।
ওয়ালাইকুম আসসালাম।